All right, welcome back. We're going to get into the meat, the real heart of algebraic proof today on this video. So we'll just do it by going through some examples. Show that the sum of any three consecutive integers is a multiple of 3. So the first step is we need to use the algebra to write this down. Get an expression, 3 consecutive integers. Well, if n is my first integer, we can use any letter we want. We tend to use n when we're talking about integers. You could use x, you could use y, anything you want. So that's my first integer, and this is again the problem that Bart did not a very good job of proving on our previous video, right? He just said, well, 5 plus 6 plus 7, those are consecutive, they add up to 18, which is multiple of 3, therefore it's true. But we didn't check 1, 2, 3, 2, 3, 4, and so on. So if n is my first integer, what's the next one? Well, the next one would be n plus 1, right? Whatever n is, n plus 1 is the next one, and the next one would be n plus 2. So those are my 3 consecutive integers. The key on these problems is going to be how we write down our numbers at the beginning. So it says the sum. Sum means to add. So what's n plus 1? You don't have to have the brackets. I'm just putting the brackets there to make it clear which my numbers actually are. Plus n plus 2. That is the sum of 3 consecutive integers. Now how can I show this is a multiple of 3? Well, let's simplify here. N plus n plus n is 3n. 1 plus 2 is 3. So is this a multiple of 3? Well, we can sort of see that it is, but when we finish our proof, we have to make it explicit. If we want to prove something's a multiple of 3, we need to write it as 3 times something. Well, we can factorize, can't we? We can bring out a 3. 3 times n plus 1. That is a multiple of 3. It's 3 times something. That is going to be our last step of our proof, right? We've shown, you don't really need to explain anymore. We've shown that it's a multiple of 3 because it's 3 times something. Whatever n is, add 1 to it, multiply by 3, it will be a multiple of 3. We have proved this is true for any 3 consecutive integers. Okay, show the sum of any 4 consecutive integers is even. Okay, well, what's my first one going to be? Well, I want to make sure that no matter what n is, I have even numbers. I can't just say n is even, right? Because n might not always be even. I want to be able to put any number in for n. So my first one is going to be 2n. Okay, because whatever n is, 2n is even. What's the next? I want consecutive even integers, things like 4, 6, 8, 10. If 2n is my first one, my next one is going to be 2n plus 2. That's the next even number. The next even number, 2n plus 4, and the fourth one would be 2n plus 6. Those are 4 consecutive even integers. No matter what, even if I choose n to be 3, which is odd, these expressions will give me 4 consecutive even integers. 2 times 3 is 6, add 2 is 8, add 4 is 10, add 6 is 12. Okay? It's the sum of any 4. So I'm going to add these together. So 2n plus, again, I'm just going to use brackets to make it clear what I'm doing. I'm adding these consecutive integers, 2n plus 4 plus 2n plus 6. I'm adding 4 consecutive even integers. I want to prove this is even. How can I prove this is even? Well, all even things, my little hint here, right? Anything that's even is a multiple of 2. So think what we did last time. A multiple of 3, I had to write it as 3 times something. To prove something's even, I have to be able to write it as an expression, algebraic expression, 2 times something. Well, let's try simplifying. 2n plus 2n plus 2n plus 2n is 8n. 2 plus 4 is 6 plus 6 is 12. Okay, that's great. I want to write it as 2 times something. Well, I can factor out a 2, can't I? If I factor out a 2, I'm left with what? 4n plus 6. Okay, now notice this is usually we factorize this and they have a highest common factor of 4, don't we? So, but we're not factorizing it just to factorize it. We're trying to prove something, that it's even. So I'm going to write it as 2 times something. So now any number I choose for n, it can be odd, it can be even. I stick it in there, I'm going to multiply it by 4, add 6, and whatever I get, I'm going to multiply by 2. Therefore, it is a multiple of 2. Therefore, it is even. I've proved it. This is my working out. Okay, if something's even, it's a multiple of 2. I can write it as 2 times something. Okay, let's just practice writing the sort of the first step of a proof, okay? Consecutive integers. We sort of talked about this. Well, they could be, say, n plus 1, n plus 2, and so on. All right, those are consecutive integers. Again, we're not talking about odd or even. We're just talking about any integer. An odd number, again, we sort of looked at this, right? 2n plus 1. That guarantees me an odd number, no matter what n is, whether n is even or odd. Right? Again, we don't know what we're going to choose for n. So 2n plus 1 is an odd number always. An even number, guaranteed, 2n. Okay, two consecutive odd numbers. Well, if 2n plus 1 is one odd number, what's the next consecutive odd number? I have to add 2. That would be 2n plus 3. That is how I would write two consecutive odd numbers, no matter what n is. I don't know what it is. Everybody's going to choose a different n. Odd, even, I don't know. 2n plus 1, 2n plus 3 are consecutive odd numbers. Two odd numbers. Now there's a difference. Notice the difference. They're not consecutive anymore. It could be 3 and 117. So I need to use two different letters. 2n plus 1 is one odd number. I can't say 2n plus 3 anymore because it doesn't say consecutive. I would have to use a different letter. Maybe use m. Okay, m could be anything I want also. 2m plus 1 would give me an odd number. This gives me two odd numbers. They might be consecutive, they might not be. Read the question carefully. Are they consecutive or are they just two random odd numbers? One less than a multiple of 5. Well, a multiple of 5 would be 5n minus 1. Again, these are all things that you might see at the beginning of a proof. A number that when divided by 4 gives you a remainder of 2. Think about how multiplication works. Right? Well, 4n would give me no remainder when I divide it by 4. So 4n plus 2 would give me a remainder of 2 when I divide this by 4. Any number I choose for n, odd, even, big, small, positive, negative, whatever, put it in there, multiply by 4, add 2, and then if I then divide that answer by 4, I will get a remainder of 2. Right? These types of expressions are the key to laying out, to beginning any proof. So let's look at some more examples then. Prove the sum of 3 consecutive even numbers is a multiple of 6. So we just sort of looked at that. 2n, right, is any even number. Consecutive, 2n plus 2, 2n plus 4. The sum means I'm adding them. So 2n plus 2 plus 2n plus 4. I'm adding them. I want to have a multiple of 6. Add this up. That's 6n plus 6. A multiple of 6, I have to write it as 6 times something. Factor out of 6. I've proven that the sum of 3 consecutive even numbers is a multiple of 6. Now I want to show you another way that we could begin this. Okay? If 2n, we'll see some examples where it's handy to do it another way. If 2n is a even number, right? 2n plus 2. Okay, well also 2n minus 2. Think about this for a second. Are those 3 consecutive even numbers? Sure they are. Whatever I choose for n. If n is 5, 2 times 5 is 10. If I add 2, takes me to 12. Take away 2 takes me to 8. I've got 8, 10, 12, 3 consecutive. Why would I say that sometimes this way is going to be handy? Well, we're going to do some examples. So I want 2n minus 2 plus 2n plus 2n plus 2, right? I'm summing 3 consecutive even numbers. 2n plus 2n plus 2n is 6n. Minus 2 plus 2 is 0. I get 6n. Well, that's obvious, right? Notice there's actually one less step when I did it this way. 6n is obviously a multiple of 6 because it's 6 times something. So I just wanted to point out 2 different ways. We're going to see sometimes doing it the way on the right can save you a lot of time and make things easier. Okay, last one for this video. Prove the product of 2 consecutive odd numbers. Now we're talking about product. Consecutive odd numbers is always one less than a multiple of 4. Okay, so odd numbers, right? 2n plus 1, right? That's my first odd number. Consecutive, the next one is going to be 2n plus 3. Okay, I want to prove the product. So I need to multiply these together. 2n plus 1 times 2n plus 3. So let's multiply them together. I get what? 4n squared plus 6n plus 2n plus 3. Okay, I can tidy this up. 4n squared plus 8n plus 3. Okay, so what are we going to do now? This one is a little bit trickier. Sometimes you need to look at the end to help you figure out what. So far, so good. I want to write it as 1 less than a multiple of 4. So at the end, I want to write it as 4 times something minus 1. Well, let's look at what we've got right now. Do we have a minus 1 anywhere? No. But can I rewrite this so that I do have a minus 1? Well, think about this. I could say this is 4n squared plus 8n plus 4 minus 1. All right, because plus 4 minus 1 is the same thing as 3. Now, how did I know to do this? Because I'm looking at the answer. I wanted 1 less than a multiple of 4. So now what can we do? Look, I can factor out a 4 from here, can't I? Okay, so I'm going to have 4 times n squared plus 2n plus 1 minus 1. I've done it. 4 times something is a multiple of 4 minus 1. So that's my proof. Okay. Again, sometimes we have to, on these harder ones, sometimes you need to look at the end, see what they're trying to show you, and then how can you rearrange to get that. Now, there's a different way we can do this, so let me rub this off, and then we will talk about a second way we could have started and gone through this. Okay, product of 2 consecutive odd numbers. Well, again, if 2n plus 1 is 1, I could say 2n minus 1. Those are consecutive, aren't they? Okay, if n is 3, 2 times 3, 6 plus 1 is 7, and 2 times 3 minus 1 is 5. I get consecutive odds. What do I get when I multiply these? 2n plus 1, 2n minus 1, multiply my brackets, 4n squared, minus 2n plus 2n minus 1. That's 4n squared minus 1. I've done it. I've just proven that this is 1 less than a multiple of 4. Notice how much easier this way was. I can get there both ways. Sometimes think about how you're going to go ahead and do it. Okay, so that takes care of this video on proof. From the news, look at what's going around in the world. Some countries are starting to open up just a little bit, starting to open some shops. Even in Germany, they've opened some schools. We can only hope that that's a positive and that things are getting better. But, however, this is a bad sign.